Connectors. Quality work is the product of highly trained professionals who strive to do a job right the first time. In this program, you will be presented with work procedures required to install connectors on electrical power lines. By following these procedures, you will help to ensure public safety and the safety of linemen who will work on the same lines in the future. Studies have shown that one of the leading causes of line failure and power outages is the incorrect installation of connectors. For this reason, the objectives of this course are to provide you with the information required to identify the correct connector for a particular size of conductor and identify the correct size of dies for the different sizes of connectors. The procedure used to prepare the conductor will ensure a low-resistance electrical connection. Finally, the appropriate techniques will be demonstrated to install compression connectors according to the manufacturer's recommendations. Connectors are installed anywhere two electrical conductors need to be joined together. A properly installed connector will provide a low-resistance joint. Connectors are used on primary and secondary lines, including service drops. Connectors are not to be used where tension is a factor. Sleeves are used where tension is a factor and detailed in the sleeves program of this series. Terms and definitions. Connector. A connector is used when you must maintain a low-resistance connection between two conductors. The mechanical strength of a connector is not as strong as the conductor itself and should not be used to splice conductors under tension. Conductor. The conductor is used to transport electricity from its source to the end user. Usually, low-resistance metals such as aluminum or copper are used. Resistance. Resistance is the opposition to the flow of electrical current. High-resistance connections result in power loss and should be avoided. Conductivity. Conductivity is the ability of a conductor or a connector to conduct electricity. Where less resistance is present, conductivity is higher. Oxidation or corrosion. Oxidation of aluminum is the direct result of contact with air. Oxidation is highly resistive, and if not removed before installing a connector, it will increase the resistance of the joint. Tools and equipment. The tools used in this video are a manual compression tool, a wire brush and gloves. The hand-operated compression tool is used to install connectors, sleeves, and other fittings throughout the distribution system. The compression tool used in this program has two fixed dies, which are located in the head of the tool. The dies are used to install different sizes of connectors. The dies are labeled O and D3. The D3 die is also used as a seat for removable dies. Further information on the care, use, and maintenance of compression tools is detailed in other programs in this series. A wire brush should always be used to thoroughly clean any oxidation or contamination that may be present on the conductor prior to installing any electrical fitting. Connector information. All quality connectors have information stamped or printed on them and their packaging, which provides the following information: the maximum and minimum sizes of conductors they will accommodate. Connectors have two grooves, which are identified as Groove A and Groove B. The writing under these titles indicates the maximum and minimum conductor sizes the grooves will accept. In this example, the connector's grooves are the same size. The maximum conductor size for groove A and B is number 1 STR, and the minimum number 6 SOL. STR indicates stranded cable, and SOL a solid conductor. Caution: Do not attempt to determine connector size visually. Always read the data on the connector. Connector tolerances are precise, and incorrect connector selection will result in premature failure of the fitting. Inside the grooves of a connector is anti-oxidation paste. This is present to inhibit the oxidation of the joint after the connector has been installed. This paste helps maintain a low-resistance connection. If the connector does not have anti-oxidation paste in the grooves, do not use it. Die size is also indicated on the packaging and connector. It is important to select the correct size die required by a connector. Each connector requires specific dies to provide the proper compression during installation. This particular connector requires an O-type die for its proper installation. Always check that you are using the proper die. The number of crimps required by a connector is also indicated on the packaging and connector. The crimps required by different connectors vary. For example, the larger connector shown here requires 4 crimps, and the smaller, 2. Read the information provided and follow the manufacturer's recommendations. Conductor preparation. Use a wire brush to clean the conductor thoroughly to remove all oxidation and other contaminants. This will ensure a low-resistance connection. Never use a knife to clean the conductor. This damages the conductor and does not clean it adequately. Always use a wire brush. Connector installation. Once the appropriate connector and dies have been identified, the compression tool is checked for calibration and removable dies installed if required. Prepare the conductor by wire brushing. Then, place the conductors to be joined into the grooves of the connector and close the metal tabs. Position the compression tool over the connector and crimp until the required number of compressions are completed. As always,